My name is Andy Kuszak. I live in Northwest Arkansas. Um, I have been in and around construction my whole life and part of some type of trade almost my entire life. There's a 4-year period where I tried to work in an office and that just did not go well. Um, and so I went from residential construction for about 10 years and then went into commercial construction, was on a traveling construction crew. We built casinos and hotels in universities across the United States. And then I had some rental properties. And in that process of buying and selling rental properties, I became aware of the home inspection industry and then decided that it was a really good fit for me. So I've been in business now about 9 years, and it's been gangbusters. A year ago, I decided about 5 years ago, we started to look at what it would take to start a specialty trade school. Wasn't really anything of that type in my area. So, in that whole process, it's taken about 5 years. We finally reached out to InterNACHI, became partner school with them, reached out to my local community college, working with them and using their facilities. And we're just starting to get up and going on doing Arkansas continuing education and initial licensing and doing webinars for InterNACHI. So I was asked to do this deck class. And, we have a lot of we have a lot of experience on decks here in Northwest Arkansas. Most built wrong, at least some aspect of it, and so I'm even putting this class together, and I was still learning stuff. So here we go. So see if I can get this whiteboard to work. Here we go. All right, let's start out here. So, what you need to inspect a deck. Um, the ideal tools you're going to be using are flashlights, measuring tapes, ladders, level, plumb bob, probing tool, hammer. We got all this stuff here. Probing tools, super important. Tape measures. Because a lot of the stuff that we're going to be going over are how to identify later in the slides is how to identify spacing and how far away spacing should be based on the length of the board and so on and so forth. So all that stuff is good. Other stuff that you might need are moisture meters, magnets. Magnets are going to be used to check if your fasteners are metal, are steel or not. Making sure that you have the correct fasteners in there, and then a calculator. InterNACHI estimates that 45 million existing decks, only 40% are completely safe. I would say that is completely accurate. We, I still see new construction decks built wrong all the time, especially when it comes to fasteners and flashing. About 90% of deck collapses occurred as a result of the separation of the house and the deck ledger, allowing the deck to swing away from the house. It is very rare for a deck floor joist to break mid-span. And then the Product Safety Commission estimates that more than 6,000 people are injured each year in incidents involving the structural failure or collapse of a deck or a porch. When you inspect a deck, we always recommend inspecting from the bottom first. That's because you want to make sure that that deck is going to be safe for you to walk on. So you want to inspect the deck in much of the same process as deck construction. Inspectors should start at the bottom. If a deck is deemed unsafe from underneath, the inspector should not walk onto the deck. The inspector should stop and report any safety issues. Image above depicts a typical deck load distribution. People tend to gather near the railings of the deck, and so more load is likely carried by the posts. And you'll see later in the slides how the code for the deck railing support posts has changed, specifically because of this fact where people are more likely to hang out on the railing edge. The IRC provides design tables for decks up to 10 PSF, pounds per square foot dead load, and 40 PSF live load. Most decks over here. Most decks are designed and built for loads of 40 to 60 pounds per square foot. Excuse me, let me silence this. Oh my gosh. There we go. The IRC R301.2 includes snow loads of 50, 60, and 70 PSF. A 40 PSF live load is equivalent to a 200-pound person standing in every 2.5 feet by 2 foot area of the deck. That's a lot of people standing near each other on a deck. So might seem a little overkill, except if you decide to have a massive party on that deck, or you decide to start putting other structures on the deck. Stairways also must support this load, but in addition must support a concentrated load. So that would lead you to believe that the deck stairs are probably going to be a lot more important to make sure that they are structurally sound than percentage-wise than the rest. Like I just stated, hot tubs require framing that can support more than 100 pounds per square foot. A lot of times, people have the greatest intentions. They want to elevate their living standards. They want to do all this stuff, and they make a lot of assumptions as far as deck structure is concerned. But yeah, anytime you see any type of structure on a deck, especially one that's going to hold water, you want to make sure that you are especially focused on the structure underneath that deck. Engineered or alternative designs for supporting a hot tub may be necessary, but may be handled with an over design in the joists, beam sizing, spacing, or spans. Footings and posts. Exterior deck footings should be installed at least 12 inches below undisturbed ground surface. Required footing depths varied based on local building codes. The depth is normally below the frost line, or 12 inches where frost lines are not applicable. A lot of times around here, you're going to see, the precast concrete supports. Those sitting on top of the ground do not meet the footing standards. The 7-foot rule: the best pressure treated wood for ground contact within 6 inches is wood classified as UC4A or UC4B. This is your typical pressure treated wood. I went and got, and I know you're not going to be able to see this, but this is the end tag of a pressure treated piece of lumber that we have back here. It's the 2x10. And the only way to know that this was that this is ground contract rated is by the end tag, which a lot of us are not going to see this end tag unless it's a new construction and they just leave it on. And it actually says on the end tag UC4A. Well, yeah, UC4A is on this end tag. But that UC4A is not stamped on this. The only stamp that you see on here is the SPIB, means this is Southern Pine. Appearance grade is the number 2 prime. Over here, the KD means kiln dried at 19% moisture. And that just means that this piece of wood was dried down to 19% moisture. That whenever anything is pre-dried or kiln dried, that is intended to keep the board from warping and twisting. So if you have a piece of green wood that was not kiln dried, then you're more likely to have warping and twisting in that board. So that's what that means. HT is heat treated. So this little area of this stamp, this is where you would see pressure treated, PT for pressure treated. This is HT for heat treated. And then you have the mill number, which is where it was where it was manufactured, where it's manufactured at. It's 146, and I believe this is somewhere in Oregon. Other than that, trying to identify if you have ground contact treated wood, you're looking for the green or blue hue in the wood. Again, if you have an older deck, it might be a little hard to tell, if it is, but you got to just try and do your best. If you were able to, compare a non-treated piece of wood to a treated piece of wood, you should be able to see the difference, but you might not have that capability in the field. You just try to do your best. The illustration below depicts the 7-foot rule. On steep properties, the slope of the ground around the footing could affect the footing stability. The 7-foot rule states that there should be at least 7 feet between the bottom of the footing and daylight. So yeah, basically, obviously, if this is going to be any type of structure is going to be built on a hill with a slope, just that tape measure and make your measurement and see what you come up with. Anything below that, just pay special attention and make sure that you're using your awl or a thin screwdriver, poking in around where it's in contact with the dirt, seeing how deteriorated that wood is. Ideally, you want that wood to be above grade, where you have either the concrete coming above that grade or something coming above that grade. Even though it is rated for ground contact, best practice is that that wood is not in contact with the soil. Obviously, it's okay that it is, but best practice would be that it's above grade, because anytime any wood is below grade, it's going to deteriorate than the wood that's above grade. So just keep that in mind when you're using your inspection tools. Footings. The image depicts a post base that is not attached to its footing. Posts should be connected to their footing so that the posts don't lift or slip off. This is a good picture of that precast footing. But again, in this instance, you would really want either a concrete footer underneath this or a rock base, that goes down 12 inches below the level or below grade, and then make sure that you have some type of connection between the wood post and the concrete. I'm not paying attention here to your questions. Next. The image to the right depicts a proper post-to-footing connection. Posts should be connected to their footings so that the posts don't lift or slip off their footings. So and you might see this a lot too, is that maybe the calculations that the contractors did during construction were not really perfect, and so you might see where the metal connector plate is off to the side or even hanging off of the footing. If you read the Simpson Strong Tie installation instructions for this connection, all of the metal has to be completely bearing on the concrete. Otherwise, it would be something that I would call out. You put all of that stress and that load on the edge of that, you're very likely going to crack that base, and just going to have settlement problems. Those pyramid-looking bases aren't even rated to be above ground, though, right? If you have no, they're not on their own. I have seen them to where you dig out, you dig out the earth, you put, 3 inches of rock down, and then you could potentially put that precast concrete on there, but you are, that's, so I'm getting a little sideways here. So I've seen that in crawl spaces, but being outside, if more than likely that the earth around the that hole that you dug for the rock is going to fill in over time. So again, yeah, you're probably it's not ideal in any situation. You really need a proper footing, at least 12 inches below grade, in order to meet the standards. Yeah. So Is this acceptable? It is not acceptable. So the rule, let's see, I had my note. Where did it go? Um, that's what it is. So anytime you're pouring a footing like this, the base, the support base, the concrete support base needs to be 3 times the size of the post. So if you're looking at a 4x4, then you need a 12-inch. Then you need a 12-inch footing base. And then you just need to go up from there. So this we would not consider acceptable. More than likely, this is going to crack. As the post and the footing ages. And wrong. So this is a little extreme, but another good reason why you might want to carry a plumb bob with you is, checking to see how plumb your deck and support posts are, making sure that everything is in line, everything is properly supported. The rule of thumb is 1 inch out of plumb and 8-foot height is considered potentially unstable. So with plumb bob, you can be able to check that. You can, if you have the right calculations, or you're carrying a calculator with you, or your phone, then you can do the calculations if you have a level with you, and then do your measurements, your calculations with your level. Non-typical columns may be functional. They need to be evaluated on an individual basis. All the rules apply. Plumb, secured at the top and the bottom, and a continuous load path. So I think we all probably see all the time where methods and materials do not meet standards. And for whatever reason, it could be working. And there could be no evidence of defect. If this has been, this is a rough example, obviously, but if this has been in this configuration for 40 years and there is no evidence of premature deterioration, then I would just, probably recommend monitor, continual evaluation. This is extreme. I wouldn't do that on this one, but this is a little much. But the premise is still there. There's lots of different ways to do construction, and if you over-engineer something, it might not meet standard, but it might function. So I would just do a monitor and recommend continual evaluation and go from there. The IRC did not say much about post sizing, but tall 4x4 posts twist under load, and 4x4 posts, even when treated, decay below grade too quickly. In all but the lowest of decks, deck posts should be at least 6x6 and no higher than 12 feet. 14 feet is acceptable if cross bracing is used. The American Wood Council says that 6x6 posts are the minimum recommended size, and maximum height is 14 feet, even if 8x8 posts are substituted. Now, there is a good, the American Wood Council has a great document out there called the DCA 6 standard. It's definitely very generalized. It's not, and it's generalized for the entire state. So your state might be different, your local AHJ might be different, but it is a really good document to read through to get an idea of, general deck standards, general deck construction. And it really takes everything from, it takes a lot of items from the IRC, it takes a lot of standards from the American Wood Council, and it puts it all in a very easy to read, comprehensive document that can really help your understanding in deck standard construction. Definitely can't hold contractors to it, but it is really good for your information to keep in the top of the mind as far as heights, spans, distances, wood types. Wood decay. Most common form of decay is wood rot from fungi growth in the wood. Fungi breaks down wood and weakens it, and it can lead to catastrophic failure. Inspectors should probe or pick suspected areas for soundness. This is probably one of the biggest things that you're going to be inspecting for when you're looking at a deck. You know, your inspection awl is going to be your best friend. Um, and you know, you might, and you'll see a couple pictures here later. The deck could look great. It might be painted and it looks really sound and good, or it could not be painted, but the face of the wood has very little defect in it. But once you start stabbing with your awl, you'll, I mean, amazingly more times than I would care to count that awl will just go right through, and it's very shocking when you don't expect it to. You know, it looks sound, it looks like it's structurally good, not a whole lot of other visual defects. So one of the greatest things you can do is just probe as much of that, especially the ledger board, your post below grade, and then even your, you know, well, you'll see here in a second, once you get down to where you start to see some of this fungi growth, um, you know, I think the deck product that is, it might not be this product, but I think it's called like Redeck or Deck Over or something like that, but where it puts a super thick layer of material over the deck to help hide a lot of the deterioration of the wood splitting, cracking, and all that kind of stuff. So, you know, if this, a lot of times people will put that covering over to kind of cover up some of the rot, all that, you know, especially when selling the home, they want to, you know, make it as look as good as they can. So, so this is a good picture. This is kind of what I was talking about before. You can see a little bit of the warping where the deck is starting to, the deck face was starting to separate there, even before the picture was taken where he shoved the his screwdriver through there. But you know, the connector is not sunken in too bad. You do have a popped nail over here, but all in all, I mean, you probably wouldn't expect that screwdriver to penetrate as deep as it did there. So pay extra special care to you know, probing the structural members of the deck. And again, I think a lot of this, coming back to here, to this picture, there's no flashing. Now, I don't know what's above this, but if this is rotting out, more than likely you have water penetration coming down from the top here. And without that flashing, it's just soaking right into that wood. And this is the beginning. You know, when you start to see the white fungi growth, this is the beginning of deck rot. You see this a lot, you know, especially where, you know, you have your beams. And I think if you have a deck contractor that's really taking, you know, really conscious of their deck construction, what they're doing now is they're putting self-adhering or self-healing, self-adhering like ice and water shield or flashing tape over the top of these joists, primarily to stop this type of deterioration. Because that water, when it rains, is being held between the deck floor and that beam or that joist, and it's not really given enough time to evaporate. If you have a lot of tree cover that is, you know, covering this deck that's not getting direct sun, then that water is staying in between that joint longer, and it's just slowly over time it's causing more and more deterioration. So yeah, pay special attention to where the deck boards, the floorboards cover over a joist or cover over a beam. Probe those locations, and obviously you want to notate those, put those in your report as needing repair, needing maintenance. And then you're going to get further down in here where you're going to start to see report early stages of wood rot, where you start to see that growth. But this is starting to get more advanced into that wood rot. You know, the rot starting to travel down, further down, and especially on this one, you know, you don't have a separation. There's no separation between your deck floorboards, and so again, you're getting that lack of air movement. Um, you're getting that lack of sun exposure, and all of that moisture is just being held between the floorboards and that deck or that deck joist. Just continue to rot. This is where you're starting to see the advanced mold or the fungi growth. It's starting to get thicker, travel downward. Definitely deteriorating. Down
Hey, Andy, I think we have an actual question this time.
here. Yeah.
Landon asks, in probing and poking holes, do I need to be concerned about homeowners alleging damage to the deck and hand of an inspector?
Um, no, I mean, I wouldn't go crazy for sure. I wouldn't go and start, you know, just jamming holes in everywhere because, but you know, I would representative amount. You know, we use that term a lot in this industry, representative amount. So you know, maybe if you find you know, one rotten area on the edge, you know, go 3 or 4 spans down, probe again. You know, you don't have to, you don't have to waller the hole out, and you don't have to put a ton of pressure. You don't really have to stick, you know, the thing all the way in. If you just give it a little tap, see how the wood reacts. You know, if it goes in at all, that would be a good picture, and then go from there. You know, and then I wouldn't just do one area. You want to see how extensive it is. So, but you don't want to go crazy either. I would say, you know, use your judgment. But I wouldn't be too worried um, about the homeowner being mad about it because the lack of structure is already there, and so I would turn it on him and say, hey, you know, we found this is kind of scary. Or advanced. You know, I don't know if you want to use scary or not, but this is kind of some advanced deterioration, especially if it has to do with the ledger board. Say, you know, if it's as extreme as that picture was, and it's that bad, you know, every 3 or 4 bays all the way down. I This is probably a safety issue for me, and I would recommend you know, this is something I would tell the homeowner because you know if they you know, if your inspection falls through or the job falls through for whatever reason or the purchase falls through, and then they decide to have a party on that deck, um, you know, until the next buyer puts an offer in, and then that deck falls off the house. You know, I don't know if you would necessarily be held liable, but if you were to warn the customer that you know maybe that ledger board is not the most structurally sound, you might want to have that looked at because you know if you happen to have a family gathering or whoever over, um, you know you want to save you want to save somebody from you know heartache and hurt. So in this instance, if this damage were continuous along that ledger board, I would tell the home. And so if they do get mad about something like that, you know, there's only so much you can do. I think people, um, you know, people's emotions are heightened during during an inspection process. There's a lot of emotion that goes into their home. If they were super proud of it, they're the ones that put this deck up, and you're coming in and you know saying that there's a lot of stuff wrong with it. Um, you know, that's just something that comes along with the industry. I would much rather make sure everybody's safe than worry about them being mad that you poked a hole in a piece of wood that is already obviously deteriorated to the point of structural integrity is in question. Here's another good one. Again, your probe tool is your best friend when it comes to decks, for sure, and the hammer, hammer too. We're going to get to that in a minute, but you know, hitting your bolt heads or your lag screw heads with the hammer, also super important to make sure that you have positive connection with that ledger to the house. We'll get those here in a few minutes. Again, this is just advanced deck deterioration, looking from the deck floor down, looking from on top of the deck down. Very common. So, and I think we've seen this, and you might be familiar with this anyway, but very, very common that, everybody paints their deck, but, they don't paint the edges. So a lot of times that, when you don't paint the edges, water is still going to soak in from the unprotected edges, and it's going to rot from the edge into the board. So, pay special attention to the edges. Same thing goes with any wood, really, on the exteriors. You want to pay special attention to the edges of the boards, both on the sides and on the end cuts, just to make sure, see what kind of rot, see what kind of deterioration is there, and then to recommend to your buyer or your client that, you need to pay special attention to these areas. If they start to rot, like here in this picture, this picture over here, this looks like it's on like the end joist. This one looks like it's midspan. So the deck joist that's right below this is probably rotting, along with the deck floor board here. So yeah, definitely pay special attention to all those areas. Again, another reason to put flashing tape or some type of self-healing membrane between the joists and the deck boards, and making sure you have good spacing between your deck boards, so that debris does not build up in between the joints. Water can easily drain from those joints, and try and get as much sun to those areas as possible. But everybody loves having a house in the woods, but the homeowner needs to be aware that anytime you have a house in the woods and you don't get that direct sun contact, you don't have constantly blowing wind, all that kind of stuff that helps to evaporate that moisture out. You need to pay special attention. You're probably going to have to do more maintenance on a deck like that than if it were out in the sun, with no tree cover. You'll get more UV deterioration, but the moisture deterioration is what really starts to cause you structural integrity issues. This is just more fungi growth growing on the bottom of the joist there. You can kind of see streaks of it all the way through. Looks like you do have a little bit of light coming through. I mean, obviously, I think that's probably water stains in the back, maybe, but that does show that you do probably have some good spacing in between there. But this might be tree covered, so you're not getting a lot of sun contact type of stuff there. And then you get the advanced growth. So mushrooms growing directly out of the midspan of a board. That's it's a clear sign that you have some issues, but not uncommon. I mean, all of this stuff I see. I mean, I would say any deck that's older than probably 10 or 15 years, you're going to see a lot of this stuff. It's just the nature of wood on the exterior. But that doesn't necessarily mean that you can let it go. It is our job to make the buyer aware of these things, and to let them know, what the maintenance that goes along with having a deck on the exterior. Look at these questions here. So, Roberto, your question, where would the flashing have to be exactly in this picture and what types? I think you were probably referring back to our good picture of that picture there. So you're looking galvanized metal, galvanized flashing. That comes over that ledger board, and there's more pictures of this later in the slides. But yeah, it should definitely come. Well, it's hard to explain in this picture, but we'll get to it here in a few slides. Let me see here. Anybody else? Sometimes tapping with the back of the screwdriver can provide enough confirmation of decay. I agree with that. Structurally sound. James, you're right. We shouldn't say structurally sound. I mean, talking inspector to inspector. That is how I want to portray that stuff to you. But yes, when talking to a client, we don't want to talk about engineer type comments. We don't want a homeowner to think that we're an engineer in any way unless you actually are. But inspector to inspector, just trying to get the point across as far as talking about structural soundness, that type of stuff. Also on flashing, Andrew was mentioning a newer standard for membrane type flashing on top of the beach floor joists. Contact with you. Yes, thank you, Kevin. All right, let's keep going. All right, fungi. So I did want to something that talking about fungi real quick, and this kind of goes along with house structure too. Is that dry rot? Dry rot is a characteristics of fungi. So when we talk about dry rot, and a lot of the stuff that we're seeing on decks is dry rot, or can be dry rot, and that dry rot occurs when fungi, certain type of fungi gets wet, and then it dries out, gets wet, and then it dries out, gets wet, dries out. And that's a lot of times where you'll see where the face of the wood still looks like it's good. It still looks intact. It might be discolored, but you don't see it's not falling apart on its own until it gets way advanced. So just keep that in mind as far as dry rot is concerned. Is you can wood can always not always wood can look sound, but that's why the probing is so important. And dry rot is part of it, along with all these other types of fungi. And there's hundreds of different types of genuses, and they all kind of do the same thing. They're all feeding, and they're all feeding on the wood fibers in the and so that's a lot of the reason why the face of the wood can still look structurally sound, is that especially if it's been painted, because the dry rot just its little tentacles just travel through the interior of the wood and is eating as it goes, but obviously it needs moisture to eat, so or to help break down the wood fibers, and it just keeps crawling along on the inside. And so, pay special attention to decks that have been painted, because the face of that might look good, but but the fungi might be traveling back behind that paint and deteriorating the structure of the wood. Lichen and fungi evidence. So yeah, the green lichen, that's just another indicator to pay special attention to. That's lichen and algae, that that area of the wood, the underside of a deck never gets sun. It's just the nature of the beast. And so it's really easy for, especially if it's in a very dusty area, that dust will get into the air. It'll settle on the bottom side of the deck. Other organisms, other fungi, mushrooms, algae, all that stuff then settles on the deck, and then it starts to, even if the wood is pressure treated, it starts to eat, the organic material that is just naturally on the wood, and then it slowly starts to work its way into the wood, and then that ongoing process over time will just start to deteriorate. And that is again why clearances are so important. You know, the underside of decks don't get a lot of sun, so you want to get as much airflow into those areas as possible. And the lower the deck is to the ground, the less airflow that is allowed to try and evaporate the moisture that's away. So you want to pay special attention to the minimum clearances. This image depicts best practice, but in the real world, there are exceptions practically in the dirt. Obviously, I think we've probably all seen that. And we see it all the time. I mean, people build decks directly on the ground all the time. But I mean, nearly or almost practically impossible to be able to inspect those decks from underneath. I mean, you can give it your best shot. Obviously, you always want to do your due diligence. You know, find the gaps that you can, shine your flashlights in every angle, you know, in every hole. Try your best to see as much of that deck as humanly possible, especially when it's super close to the ground. So you're looking at 18-inch minimum to the bottom of the joist and 12-inch minimum to the bottom of the girder, or the bottom of the beam. Continuous load paths. We have a hard time with this here in Northwest Arkansas. Everybody still wants to use through bolts that are, face connected, with no notches, no additional supports. I think more and more contractors are getting better at this, but I mean, I still find new construction decks all the time. And your AHJs, our AHJs, our local code officials around here don't inspect anything deck concerning. Nothing ever. So that then it falls on us as inspectors to call this stuff out, which can be very hard. Because obviously, I think we've all heard it's the code or the code inspector signed off on it or whatever. So in these instances, I would just say, hey, if they do come back and they say, oh, the code inspector signed off on it, or this is to code or whatever, say that's not my purpose. My purpose is to point out potential safety issues. And this, in my opinion, is a potential safety issue. We see a lot where this connection over here on the picture on the left, the diagram on the left, when they drill this hole, this is a great place for water to get in back behind the bolt and the washer, and then it's going to start to rot out that hole. And so that's exactly why this is no longer recommended. So probe this with your awl. Make sure you're probing around, all of your through bolts, through all of your lag or your lag screws, your screws, your lag bolts, making sure that it is still in good shape. And then if they don't, if it is not notched into this support, then I always recommend adding either additional like strong tie hardware, metal hardware, or additional blocking down below here. Just something else to help keep that up. Because once this rots out, yes, I do recommend a sealer on top of the post to girder connection. Any horizontal location on wood should have some type of protection. What type of sealer? So what type of sealer is the question you would recommend? So any that like ice and water type stuff, or the zip tape, flexible flashing. It's the previous prior to this one. Can't go back. Back for a few seconds. Yeah, hold on a second, Sam. And tell me exactly what slide you want to go back to. But as far as the sealer goes, yes, you want some type of ice and water shield is a good one, or the zip tape flashing is a good one. Any type of self-healing what do I want to say, flexible type flashing is what I would recommend on any horizontal surface, any horizontal wood surface. Go back to this slide prior to this one. So you missed. Oh, so you're looking for the minimum distances, the 18-inch to the bottom. This is also the same. These minimum distances are also the same distances for your house structure. So you want 12 inches of minimum clearance to your girders and your beams for your house, and for 18-inch minimum for your joists. So the deck structural clearances and your house structural clearances. All right. All right. Yeah. So now talking about notching in. So if you do have a notch, okay, so the IRC's recommended minimum notching is on a 6x6 post. You're probably going to see 4x4 posts notched out there, but that does not leave very much. I mean, it leaves like a sliver of on that 4x4 post, especially if you're going to use a double beam, a double laminated beam. So, so again, I guess really it just comes down to is make sure you have 1/2-inch through bolts with washers on a ledge cut into a post. There is, I had to look this up a couple months back, but you can have 4x4 posts where this, at least if the beams are resting on the post, that is common. You'll see that a whole lot. Not technically wrong, not standard, not ideal. But where the 6x6 really comes into becomes a factor is when your 6x6 post is extending up into the guardrail, and that's where you run into the requirement of having a 6x6 post if you're going to notch it for a guardrail, and we'll get to that in these later slides. So these are your 1/2-inch. These are your 1/2-inch through bolts, washers on both sides, on both the hex head and on the nut side. Yeah, you want to make sure it extends all the way through. Talking about the ledger. Well, yeah, talking about the ledger. So these are 1/2-inch lag screws for your. Don't allow any notching in post. That's super interesting. Wayne Turner or Tanner says that our local building inspectors in Canada don't allow any notching in post. Okay. Huh. I'd be curious. I would like to see. Their code book as far as how they expect connections to be. Roger, this is your license to be. Yeah, galvanized, correct. Yeah. So, oh yes, and these are all galvanized. So, kind of going back to, I think we're going to get to this later, but galvanized, you really have to have galvanized or some type of coated connector when you're going to be connecting to a some type of treated wood, because this treated wood will start to deteriorate non-galvanized or non-exterior coated connectors. All right, let's use stainless. Stainless. So I'm gonna have to look. I think stainless is. Well, here we'll get to that here. Let's keep going. Oh yeah, we were talking about continuous load path. So continuous load path, again, so this is not a continuous load path. And for this support, so this is the support post. So we're missing continuous load path down here. and the anchors are countersunk into the wood, which is not acceptable. So you can't have countersunk. It has, and you have to have additional supports that come down to this post. So whether that be, strong tie materials, some type of metal connector, some type of additional support post. Can you notch in the middle of the post versus the side? There. Hold on, let me see here. Are the SST post caps sufficient for post to be in connection? Since type post caps. Post caps. Post to be in connection. Are you talking about like the L brackets? Post caps. I'd have to see a picture of the post caps to know exactly what you're talking about, Felix. I will look that up and get back to you on that one. Is there a thread protrusion requirement on the bolt? No, as long the nut has to be completely seated on the bolt, but that is all. It doesn't have to. Now, if you are connecting a screw, and this is mainly on a ledger board, but the screw has to completely penetrate through the board. So you have to be able to see the tip of the screw whenever you're going to use this for your ledger connection. And that is if it's going, through. This is obviously too short, but if you were to look at this inside of a crawl space where the ledger board attaches to the house structure, you should be able to see the tip of the screw coming out the other end. And then as far as your bolts are concerned, as long as the nut is completely seated on the threads, you should be good there. Is there a thread protrusion requirement? Okay, can you notch in the middle of the post versus the side of the post? So we are going to go through, yes, you can notch in the middle of the post. Well, in the middle, like through the post, Brian, or no, the top. Notch. The screw tip, yeah. Thank you, Brian. Agreed. Notch the middle post versus the side. Top. So if you're talking about notch in the middle of the post, you can notch in the middle of the post. I get the last slide where it shows the notch on the side. Yes, this is completely acceptable. Okay. I get this last slide where it shows the notch on the side. Okay, okay, I'm good. Let me go back to the question. All right. All right. All right, so this is just showing continuous load path of the beam to the post. This is good. And ideally, we do not now. Okay, butt joints typically must be bearing on the post, although they can be specifically engineered to be between bearing posts. A lot of this is going to factor in, like it says in here, it's got to be engineered. So if it is engineered where the posts, the force coming down on the butt joint, that force has to be able to be transitioned to the support post. So if they're close together, you're probably fine. If they're super far apart, they're not going to be fine. Again, but it has to be engineered that way. So if you see it where it doesn't look like it's been engineered, it doesn't look like it was, it looks like it was probably built on site, or there was no, I don't want to say this. If it doesn't look professional and you feel like if there can be any, if the load path feels, if you feel like the load path can be affected by the by it being over the top of the joint, then I would definitely call that out. I mean, you should ideally you should always have a support underneath a joint, and if there's not a support underneath there, you just need to pay very extra special attention to where your support posts are. You know, when you walk on that area, does it feel, is there a bow in it? Can you see a bow when you look down lengthwise? You know, you know, there's going to be a lot of factors, a lot of things that should come up if it doesn't feel like it's structurally sound or there's any flex in it. You know, you just need to use your best judgment and for those instances. But you should always have some type of support underneath the joint. Yeah, they're probably Simpson's Strong Tie. They make products for just about every situation. Um, Now, what they'll in that situation, they're probably going to have a tie that's going to go from this post all the way to this post in order to for them to carry their liability and say that it will be structurally sound. And a lot of times in those instances, uh, it would just be better to build it with a support post underneath the butt joint instead of having a strapping that goes all the way across. It's probably going to have to be on both sides. So, all right. Let's see. How far are we at? So we're right at an hour. Do you guys want to take a break or you want to keep going? Keep going. All right. We'll do some more homework on that. Thanks. All right. Thanks, Wayne. All right. Let's do this. All right. The image above depicts notches in a supporting beam. Notches must be less than. Oh, what's up?
Sorry, before you start going, there was a question. Wayne asked, maybe the notching is prohibited. Comment is meant for railing post only. Oh, never mind. It's more of a comment on the questions. Hey guys, if we can keep questions on the Q&A, it'll be a lot easier to cipher through.
Um, the notch. Okay. On the Let's see. The image above depicts notches in a supporting beam. Notches must be less than 1/4 the depth of the member. On the tension and compression bases, the notch must be less than 1/6 of the member's depth, and the notch length must be less than 1/3 of the member's depth. Notches are not permitted in the middle third of the span or on the tension face of members that are greater than 3.5 inches thick. So basically, what this comes down to is your beams should really not be notched, especially on the deck. There's really no reason to notch a 3.5 inch thick beam on a deck, on a deck post. You're going to have space above it. You'll have space below it. I think this more or less refers to structural, like your house structure. But I mean, obviously, I think there's probably going to be instances where you might see this, but I don't. I see this very, very rarely where there's a need to notch a beam or a girder. But just keep that in mind that if you do see a notch, I would just reference this diagram, take your measurements, take your pictures, and do the math. If you want to do it on site, by all means. But if you need to take it back to the house and make sure that the notches and the cuts meet the minimum standards, I would highly recommend it. This is probably what you're going to see the most of as far as notching and stuff when it comes to beams, or I'm sorry, joists. And this here we go. So this is kind of my mock-up, and I haven't hit on this very much so far, but I just did want to point this out to you guys. So on this mock-up, this is going to be mainly for a ledger. And I'll just point out a couple of things here real quick. So coming from this way, so this would be like the edge of the deck. This is a 2x10 true length is a 1.5 by 9 3/8. And then for this mock-up, this board is intended to be 12 feet long, right? So using this is 4 feet. This is a 4-foot section. So there would be the middle span of this would be another 4 feet, and then the end, the end span would be another 4 feet. So there would be, so you could notch, so you can notch in the tops. So this is kind of hard to see, but this is the notch, and I didn't mark this up because I'm gonna make another board, but this is basically the maximum notch that you can do in the top of the board. This over here, kind of hard to see, but this is the maximum notch that you can do in the end of the board. This is the maximum hole that you can cut. It's difficult to see, it's a pencil, but this is the maximum hole size that you can notch in this board. And then, and so that's for the notching. Now, and I think we're still going to get to this here in a little bit. And you kind of see all this. So basically the D has to deal with the depth of the board. So this is the depth of the board. So if you're looking at it when it's laying down, this is going to be the depth. Right? This is the depth. This is the length. This is the thickness. All right. So doing this math here, basically I did this math. So the true size of this is 9 3/8, which down to decimal point is 0.375. So then you take that number, divide it by 3, you get 3.125, which comes out to 1/8 or close to 1/8, closer to 1/8. And then 9.375 divided by 4 equals 2 inches and 3/8. Again, 9.375 divided by 6 is 1 inch and 9/16. So that's where I got all these measurements from. So if you have the D3, that's where you get that math. There is the 3/8 and 1, or 3 inches and an 1/8, and so on and so forth. I think you guys get it, but anyway, and then, well, while we're here, so once you're looking for your ledger attachments, so you have your through bolt or your lag bolt or your screw, your lag screw has to be 5 inches in from the end, right? And then doing the math for your ledger connections, you basically take the length of your board, divide it by 100, and then you get your span of how often you should see a ledger connection, a bolt or a screw or whatever. And in this instance, because we were doing the math on a 12-foot board, it should be every 1.5 feet. So we have a 1.5 feet, and then a lot of times you'll have a connector here, and then you'll have a connector here, and then you'll have a connector here, and it just W's all the way down the board. Oh, perfect. That was the next. Okay, so the most common cause of deck collapse is when a ledger pulls away from the band joists of the homes and the buildings. 21 IRC changes have created a schedule for fastener placements on ledgers. Older ledgers rule of thumb was the 100 divided by the joist length in feet. So that's where we got basically this math, is that you should see no bolts or no connection within 2 inches of the top or the bottom of the board, and then your connectors as they go along. So now the IRC is, instead of the rule of thumb, it actually has tables now to reference. The rule of thumb still primarily applies. It's not going to apply in all instances, but primarily. So as inspectors, if anything looks off, anything looks overspanned or whatever, If you don't have your code book on you, I would use the general rule of thumb and just, and then if you need to do your due diligence, take your measurements and your pictures, and then do the math back when you get back to your office or your house, and then verify and make sure. So, for example, assume a deck is built with a 40 psf live load. The joists are spanning 10 feet, and a half-inch diameter lag screws are used. The on-center of spacing of fasteners is 18 inches. The tip of the lag screw should fully extend through and beyond the inside surface of the band joist. So again, I think we already mentioned that, but you should always, if you're going to be if they use lag screws, on the opposite side, either in the crawl space or wherever the connection is, if you can see the, if it's visible, you should always see, the tip of the screw or more. I mean, I think what we say there's like an inch and a half or more of the screw. Something I did want to point out, and this is happening more and more often, is that attaching decks, solid lumber decks to I-joists, a house that's built with I-joists. You need to make sure that the band joist or the rim joist that they used for the house structure either has additional blocking that they put, if they use two I joists to make the band joist or whatever they use. There needs to be blocking in between those I joists that then the screw and the bolts will go through. Where the I joists are not, they're just getting more and more commonly used, and maybe a deck, especially if the deck is being put on after the house is being built and not in at the same time, that deck contractors, because around here, well, it's getting more common that you have to pull a permit to put a deck on, but that's only very recent in my area. And so whoever off the street could be putting decks up, and when they are not familiar with newer style construction with I joist stuff, they're just running a bolt through or running the screw through. Hey, it's solid, we're good to go, and they don't worry about going into the crawl space and looking at this the deck structure. So if your house has I joists in it, pay special extra attention to the connections for your ledger board to your house structure. Good. Here's a good point here. So the joist span, you got 10 feet, half-inch diameter lag screw. It's going to be every 18 inches versus a lag bolt. It's going to be every 34 inches. So I guess that's where the difference is coming in on the new IRC code versus the old rule of thumb. This year, in January, is when Arkansas just changed the 21 IRC code. So we're all still kind of getting used to it. This is showing that the through bolt is less than 2 inches from the edge. Again, if this deck, lag bolt, just looking at the head, you really can't tell the difference at all. I mean, I guess if markings, what, there might be a way to tell from the markings if somebody knows that for sure. More often, I always if on crawl spaces around here, you'll almost always be able to see the backside and be able to tell what type of connection that they use. But from the face of it, you might be able to tell from the stamp on the hex bolt head. I would have to look that up for sure.
Andy, we have a question. On the second story deck where the ledger attaches to the floor joist of the second floor, any tricks for determining if they use lag screws or through bolts?
Oh, no, you know what? No, here, tell you what, I think, let me, let's look here. You know, we have a second. NBZYC bolts. Let's just go see if we look up the, right, the grade and material of the bolt, how strong it is. No, I mean, this is just my very quick search on my phone here. The markings only determine what grade it is, what the metric is, and what type of metal it is. So I don't have, and maybe somebody on the webinar does have a trick, but I do not know of a good trick to be able to tell the difference. I would say, well, if you can tell that the deck was built after the original construction of the house, and barring any remodels, I would say it's almost always going to be a screw, right? Just because you would have to completely open up the interior of the ceiling from from the bottom floor to the second floor to be able to make those connections. And then depending on the spacing between all of them, you would have to open up basically that whole ceiling, the whole length of that ledger board, if you were going to use bolts. It's entirely possible to use bolts, I guess, if you're gonna do that. But from coming from construction, and if a customer is hiring you to put a deck on, and you come in and tell them, okay, I'm going to put bolts in, or I'm going to put bolts in, and I need to cut out all this, and it's going to add another, $10,000, $20,000 to put this all back together, and then to repaint, retexture, and all that good stuff. More than likely, they're going to say, well, is there a cheaper option? You're going to say, yeah, I can use screws, and more than likely, they're going to go the screw route. Now, if it's being built during construction, or during the original construction of the house, there's no true definite way to answer. I don't think. Let's see if anybody has a. It has to be lag. Yeah. Bingo. Try to loosen one and see if it backs out. If it doesn't, it's probably a bolt. Lag will thread back, or lag screw should thread back. Newer fashions may be recognizable as timber lock, etc. Yeah, all these are great recommendations. Talking about backing screws out or backing lag bolts out, I mean, you can definitely put some pressure on it and see how that pressure feels to you. I definitely wouldn't back it out too, very much at all. But if that's what you want to use, try and identify. Half-inch lags or bolts with washers on the surface. Always need washers on the surface, and making sure that the bolt is not countersunk or countersunk or pulling in. Where if you're using a bolt and you over tighten and it pulls into the wood. So the whole reason behind all that really is that the intended structural integrity of a board is intended at its manufactured state. So once you start to break the surface of that board, you're lessening the structural integrity of that area. Now that's if we were just talking about this one bolt and it was pulled in or countersunk a little bit, not a huge deal. But if you're looking at every structural bolt is countersunk or sucked into the board, you might start to see cracking along those areas. You run the risk of having potentially, cracking that wood member and lessening the structural integrity of that member. And well, I know we're going to get into this again, but we're missing flashing up on top here and below, especially if this is a framed below the ledger. But we're going to get into the flashing here in a second. Oh, over here on the right-hand side of this picture, excuse me, this is a washer that's integrated into the bulkhead. So really, as long as as long as you have something there, an integrated washer, isolated washer on its own, as long as something is there that's wider than the hex head, should be adequate. Here's one that is been pulled through, a little too tight. Nuts not fully threaded. Yeah, just needed a longer bolt. And I don't know what this is attaching to, but definitely not completely threaded. Very easy for that nut to, as somebody walks on that deck, from the vibrations of people walking back and forth, wind from storms, all of that stuff. Those nuts can back out on their own. It actually looks like this one is actually backing out on its own. That top one, you have a little gap right there.
We got a couple questions, Andy.
Oh yeah. Our current standards to build decks as freestanding so as not to rely so much on the ledger. Yes. Well, it's becoming more and more popular. I think as more and more deck failures are being reported on in the news, people are sharing on social media, it's becoming more and more standards. More and more cities, AHJs, are going to freestanding decks. Now, not all of them. I mean, here we still allow for ledger attachments and not freestanding, but it's getting, as more and more people are being hurt, damaged, and it was probably all happening before, but with the media and with social media and the media being on the 24-hour cycle, they're picking up everything all the time, and so it's getting more and more in people's faces. So the standards are slowly changing. Are you seeing ledger lock screws as well? We are not seeing ledger lock screws here, but I don't know if you guys are up in the Northeast. Do ledger board fasteners have to be staggered top to bottom? You know what? I think. Let's see. Diameter on center spacing. I don't know what the new 21 code says about that. I do think they have to be staggered though, because if you don't stagger them, then you run a high risk of cracking along the bolt connection location. So I do believe they have to be, but I will definitely double check and make sure that they do have to be staggered. Brian, yes. Yeah, so like these, this would be technically wrong if it's not staggered. Okay. Yes, ledger board must be attached directly to the floor band or framing. It cannot be on the top of siding, stucco, or brick veneer. We see attachment to brick veneer all the time. Again, it just harkens back to I know we a lot of our contractors right here. So a little backstory: my area is growing so fast. We don't have enough qualified contractors in our area. So basically, and that goes for our code inspectors too. We just don't have enough, and enough that have enough experience. And so a lot of stuff is getting missed all the time. So we're getting decks attached to brick all the time. Simpson Strong Time makes a hanger now that allows for attachment through brick veneer. I'm in your area. Oh, right, thanks. Can a ledger board be attached to the house over the siding, or must the siding be removed? Siding must be removed. So yes, you cannot attach directly to the top of siding. Siding must always be removed. Well, there's a lot of factors that go into why the siding must be removed. But let's say, well, the first one is siding must be removed so that you can correctly flash the ledger. If the ledger is not flashed correctly, then you run a very high risk of that water pouring back into the wall structure. So yes, and especially if and this is only on framed walls. So if you have, let me see, let me back up here. So if you have like vinyl siding that comes down, then you have your deck ledger, and then that's connected to your concrete foundation block or your CMUs or whatever. You don't have to flash when you're connected to CMU or concrete, but you do have to flash in every other instance. And in every other instance, the siding must be removed so that you can flash correctly. If you have framing below the ledger or behind the ledger, then both the top has to be flashed and the bottom has to be flashed. Again, we don't see that here. I almost always, we barely get flashing on top of the ledger, and even in our new construction. And so I'm constantly calling this stuff out. Can the ledger be attached to brick veneer? So I guess what the gentleman Chris makes a hanger now that allows us. So I'm going to have to look at that. I would be super interested on how they are attaching the brick veneer connection with the ledger to the brick. So that's something I'm going to have to take back and take a look at. What if the siding is just painted texture? Do you have to remove or cut the board to get to the framing? Yeah. So when it comes down to it, you have to have the structure of the deck attached to the structure of the home, and siding is not structural. And again, with the flashing, those all go hand in hand. Is that you have to attach the structure, and then to protect that structure, you have to flash it. And when you don't attach the structure, and you don't attach to, and you don't have flashing, then you run a very high risk of that deck ledger pulling off of the home. Block walls, attachments need to be sure of filled blocks or not. Where the connections are attached to the block, that cavity should be filled. Now, like we were stating before, Simpson Strong Tie makes all kinds of different things, and they might have a special connector that allows you to attach to the cavity of a CMU block, but I am not familiar with that. So that if you are attaching, we definitely need to have that built, because the CMU block, it's intended to hold or to support vertically, right? So the face of that block, your block wall. So if you're going to pour a foundation wall with concrete or a footer, you're looking at a solid 4 inches thick, 6 inches thick. And so if you're putting that horizontal stress on a CMU block, you could potentially break the face off of that CMU block without it being filled. So there might be a connector out there that allows that, but as far as I know, that block has. And I think where there's a diagram here, second things. Ledger cannot be attached to a cantilever floor unless the cantilever was engineered to support the deck. Pass through to the rim joist, does not rely on the brick. Okay, yeah, that makes sense, Kevin. Yeah, and that's what I would expect. Very good. So the ledger cannot be attached. Yes. So we again see this all the time. We don't have. I don't know if I've ever seen a cantilever portion of a house that's ever been framed out to hold the deck correctly. So I would more than likely you're going to see this type of connection. Like I said, I've never seen it framed out correctly to be able to hold that. And the times that I have called it out, every time I get called back out to go do a follow-up inspection, the contractor has come out and framed it out correctly. So it's always been a plus for the buyer. So here's just a good diagram of framing out around a cantilever. Double headers, little joists, everything basically doubled up with hangers, blocking, all of the standard connections for the actual ledger board. Yeah. Thanks, Chris. I appreciate that. Oh yeah, look at that. We did pointed that out. So this one, so they did flash around it. So at least we got flashing on there, huh? But the main issue is that the cantilever on a house was not intended to hold all of this weight. So if you're going to put a 200-pound person every 2.5 by 2 feet right on this area, that band joist of that cantilever was never intended to hold that amount of weight for that span. So it's easy failure. Same again. More incorrect framing. Image depicts a ledger attached to an overhang. Decks should not be attached to overhangs. Yeah, again, likely was never engineered or designed to be like this, or to have, well, it might have been designed like that, but maybe it was not installed correctly to have, the ledger attached. And obviously, building science, building practices and construction has changed drastically over the last, even over the last 10 years, it's changed drastically. So this might have been acceptable before we knew better. So it is our job, as inspectors, come out and say, hey, this might have been okay at one point, but you run a very high risk of the weight of the deck. If you put a ton of people on here, or a 200-pound guy every 2.5 by 2 feet, that the ledger board that this deck is attaching to the band of the house might not hold, and it's our job to point that kind of stuff out and recommend it for upgrade. All right, so now we're getting into the flashing. This is what we see a lot of. Yes, so this ledger on the left is directly attached to the siding. So I guess one of the main issues is that without this flashed correctly, without a flasher or without ledger flashing, water is going to come down and hit these bolts, and it's going to follow that bolt into the siding of the house, and or it's going to get in between the ledger and the siding, where it connects up above on top of there, and water is going to naturally flow down in between the ledger and the house here. It's going to come into contact with these screws and these bolts, and it's going to follow those bolts into the house, into that siding. It's going to deteriorate that siding, which is part of what's holding that ledger up, and then keep flowing, keep flowing into the house frame. So crawl spaces. Now this is obviously there's room back below here, so this is probably all finished out below. But if this were a crawl space, I would look on the back side of that, and almost always you're going to find some type of moisture staining. Whether it be coming through where the bolt's coming through, or if the siding has rotted up above on that connection. Uh, and I will say a lot of times maybe the siding has been pulled off up above there, but it hasn't been pulled off back behind the ledger. So all of that is just leading to moisture intrusion points. So you're going to have, and then you're going to have this the whole length of that ledger. And so you're going to have all these penetration points coming along. And so you want to pay special attention to the back side of these walls, these ceilings, or in the crawl space if you have access, and look for moisture, any type of moisture staining along those areas. And again, probably prodding the siding, especially if this is wood siding, using your probe and gently probing the siding around here and seeing if it's soft, because if moisture is getting back in behind that siding and the back of that siding is not painted, it's going to be rotting from the back side to the front where it is painted. So the front could look completely fine, but until you prod it, it might be rotted back behind. The paint is what's keeping it together. Let's see, over here on the left, this looks like stucco. And it looks like we have ground contact over here. So probably we have, so, the stucco we all know is notorious for hiding water damage. And so looks like we have maybe a lag screw with a hanger. Yep. Attached directly to the stucco. And stucco, if this is stucco, water is going to be pouring down in between this gap right here. It's going to be coming into contact with that lag screw there, and it's going to be coming into the and it's going to follow into the band joist of the house. So ideally, the stucco should be cut back, flashing installed underneath, and then over the band joist. And then I'm not sure, that might be a window well or whatever. So yeah, definitely some points for moisture intrusion here. All right, this is where we're going to get into filling the CMU voids with concrete. So this is your concrete wall, and ideally, it's kind of like, and I would say first off, I never see caulking. If you have a band joist connected directly to a concrete wall or a CMU wall, I have never seen caulking at that joint, which is important, and that you have a gap there. So it's kind of like, having the correct gaps between the deck floorboards and having that self-adhering flashing or whatever that's across the band, is because once this starts to deteriorate and warp, and you get different expansion contraction throughout the year, and that's going to cause gaps, in your band joist to your concrete, and water is going to get back in behind there, and it's going to start to rot all that stuff out, because you're not, it's not getting, and on top of that, concrete never really, ever really dries out completely. So it's soaking in water from rain, or from high humidity, and without that caulking bead there, you're just allowing more moisture to get in between your band joist and your concrete wall there. So the name of the game is keeping water out, right? Always keep water out. And if it gets in, let it out. So those are those are the two mantras of inspection and construction. We're always trying to make sure that water stays out, but if it gets in, it has a way to get back out. So again, we have 1/2 inch expansion anchors embedded 2.5 inches into the concrete. If you're unfamiliar with these, and I did not buy any of these, but I've seen these a lot, and it's amazing how much weight these guys can hold. But basically, it has just it's a bolt that has a like a bell end on the end, or a bell end, and then a little collar. And so you drill your hole, you tap the bolt in, and as you tap it, that metal collar flares out on the end, and it fills that concrete hole, and that allows you that positive connection to that concrete. Pretty cool engineering on those. I've done some wild. It's amazing how much weight those things can carry, and in all different directions, vertically, or horizontally, from up above, all that kind of stuff. Pretty neat stuff. This image depicts a ledger board and a band joist sandwiching the structural sheathing. Sheathing is permitted to be wood structural panel, gypsum board, fiberboard, lumber, or foam. Sheathing is permitted to be wood structural panel, gypsum board, fiberboard, lumber, or foam sheathing. The 21 IRC table for ledger connections allows up to 1 inch of open space between the house band and the ledger. This provides for wall sheathing and or drainage and ventilation. It is not intended for cladding, so no siding. Up to a 1/2 inch thickness of stacked washers are permitted to substitute for up to 1/2 inch of allowable sheathing thickness when combined with wood structural panel or lumber sheathing. Removing the cladding and reinstalling it properly around the ledger depends on what type of exterior wall covering is installed. So that the 1/2 inch thickness of stacked washers, that allows the contractor to be able to marry up all of the different materials that are intersecting at that point, so that everything looks good. You can flash everything correctly. It can potentially allow for water to not be trapped at that connection point. Not that you probably will never see those washers, but you might be able to see a gap back behind the ledger if there is any say washers or spacers. Spacers. All right. The IRC requires decks supported by the attachment to an exterior wall to be positively anchored to the primary structure and be designed for both vertical and lateral loads. Attachment only to the band joist may not be sufficient for lateral loads. Positive anchorage of the deck joist to the house floor framing, as shown in the figure above, addresses this potential failure. You guys might see these in your area. We do not see these tension devices in our area. I would love to see them. I think the more connection, the less likely it is that the joist is going to fall or it's going to pull away. Rot is less of an issue in this scenario. If the band joist, if the flashing fails, so there's a super thin flashing out there that is currently acceptable, but it rots and rusts very, very easily. And so we see it where it's just completely gone a lot of these times. And so in that instance, if that flashing were to be gone and it were to allow the connection of the band joist to rot, then you still have additional connection. So I would applaud anytime I would ever see this, but we have never seen it. I'm seeing and hearing a lot about code. While I try to stay on top of that, plumbing, electric, so on, it is not an SOP. Once you start citing code, you're opening, you're up. Yeah, Tim, this is for you to be able to understand what you're looking at. I would never recommend talking code to a client or anybody, but it is very important for you to understand code and how things are constructed and why they are constructed, so you know exactly what you're looking at and what to look for. So yeah, I agree. Don't speak code to your client. We're not code experts. We hear that stuff all the time, but I do think it's imperative that you educate yourself on code so you know exactly what it is that you're looking for. Let's see. Oh, there one is in the wild. Where lateral load connections are installed at the deck, the inspector should observe hold-down tension devices installed in at least 2 locations per deck, and they should be installed within 24 inches of each end of the deck. Each device should have a stress design capacity of at least 1,500 pounds. Yeah, again, I would love to see these in the wild. I really, really would. We're not quite here yet in Arkansas, but hopefully it's coming soon. Yes, the deck does look, it is integrated into the siding. And again, so more than likely this is framed, and so yes, it is missing flashing here. We do have flashing up above, and this does look like it might be that super thin flashing that I was talking about that easily deteriorates. So I think the deal with that flashing that easily deteriorates it's first off, it's super thin. Second, the coating that's on it, just if there is any scratch in that coating, if there is a dent in that coating, if they damaged it at all during construction, then it's once you lose that protective coating, it's going to start to rot from wherever that lost that coating, and it's going to start to go out. So I think that's why we see a lot of this flashing that has been rotting away over time. You are seeing them in new construction, and I'm a little jealous. I would love to see them. Here's another example. I think this is probably more likely what we're going to end up seeing more often is this type of connection. The previous connections where you have to have the all thread that goes all the way through and connects all the way through. That just seems like it's going to be a lot of work for a contractor. And I think we all know that a lot of times it always goes towards the easiest, the cheapest, and which I think is going to be more in line with probably this device here. This attachment was approved by a city inspector and without comment on the crack. Yeah. So, and here we go with filling the CMUs, CMU walls. So, again, we should have caulking, 2-line ledger, epoxy acrylic anchors. They do have these really awesome. It's a glass tube filled with a 2-part epoxy mix, and basically once you drill your hole, you put that glass tube in there, and then you put your bolt. You put your bolt in there. Once you tap it in there, it breaks that glass tubing, and that epoxy mixes together, and it creates that chemical reaction. And then it expands, kind of like your standard expanding foam. But it has to be rated for, and obviously I think anything in that instance would be rated for that connection, and that's not something that we would ever see. But it'd be cool to be a product. Hilti makes that product, yeah. All right. Image depicts the ledger board attached to hollow masonry. When the ledger is attached to hollow masonry wall, the cell should be ground. So something I just saw the other day on a new construction house is okay, question is joist tape ever a substitute for metal flashing? I would say no. I mean, I guess it's possible. It's possible, but your joist tape would have to be like 6 inches wide at least, um, in order for it to, in order for it to go up behind the siding and then, go horizontally over the ledger and then come down over the ledger. Or I guess you don't necessarily have to come down over the ledger, but in order to provide enough protection, you would probably have to use 6 inch wide tape, um, in order to have 3 inches, 3 inches up the wall and 3 inches down. I guess you could, as long as everything is layered correctly. If you have house wrap, it's underneath the house wrap, the siding goes over. As long as everything's layered correctly, I think you could probably use it. I don't see it very often because